That's really interesting that you can do it piece by piece as
Yeah.
well. At Udacity, we use a lot of Jupyter notebooks to sort of break up tasks as far as like defining a model and training it. And I think it's really valuable to look at things like one sort of piece at a time as these building blocks.
Yeah,
so I think
absolutely.
that's really great.
Like the other part that I think is worth telling is if you have a giant model, right, you might not want to change big parts of the model. So let's say there's a ResNet block. You might want to change how the ResNet looks and everything, but the blocks in the ResNet you almost never generally change. So
like they're just processing input data in the same kind of way.
Yeah, exactly. They're like an LSTM cell. Like LSTM cell is a standard definition cell. Like you might change how the LSTM is put together and how many layers there are and stuff, but the cell that's the core of it, you'd never usually change. So you can just add function annotations to like the smaller components while changing the other components a lot, which is why we call the new programming model a hybrid frontend, because you can make parts of a model like compiled, parts of model like still experimenting, and then like that just gives you the best of both worlds.
Yeah. So this hybrid front end, is it kind of allowing you to just sort of switch in between like Python and basically like a C++ representation?
Yeah.
That's really interesting. Yeah. So if I was building a model and I wanted to, is there a way that I could sort of use optimization to like train it faster, or is it strictly like these annotations are used strictly for like after a model is trained?
So all of this is powered by what we call the JIT compiler in PyTorch. So the aim of the JIT compiler in the short term is to make sure we can export everything to production ready, because we asked our users what's the thing that's most missing in PyTorch that's holding you back. They said, we use it at all these companies, like, I work at my startup, I work at my big tech company, and constantly other people around me are like, you can use PyTorch, but remember, you can't ship it to production. So we wanted to first focus and remove that big constraint, make our users happy, open up that market. But the long-term investment of the JIT compiler we made is the parts of your model that are compiled, we're going to make them non-trivially faster by fusing operations, making more of the memory bandwidth bound operations into compute bound operations. And as newer hardwares come through, we can apply special tricks that are particular to each hardware that can do various things when they see a larger graph, like make it more memory efficient and things like that.
Yeah.
But that's the longer term plan, to not just leverage this JIT compiler we're using for exporting a trained model, but also while you're training to make sure things get faster.
And so what was, before PyTorch 1.0, what was sort of the process for moving a model to deployment?
So before PyTorch 1.0, about 6 to 9 months ago, we introduced an open standard called ONNX, ONNX. And it's a standard that is not even like just focused on PyTorch. It was a standard we tried to develop where like all deep learning frameworks can talk to each other. So
it's another like formatting
that is
interim
correct.
step, yeah.
And we partnered with Microsoft, with various like big players to make sure all of the deep learning frameworks like Chainer, Caffe2, PyTorch, and TensorFlow, like all of these someone can take a model that's trained in one and then export it to another framework. So with PyTorch, the model then, before 1.0, was to always export it to ONNX and then run it in another framework, like TensorFlow.
I see.
The shortcomings of that, which we felt, were that ONNX is a standard, which means that you always have to get, like, all PyTorch models couldn't be exported because the standard hasn't developed fast enough to cover that. So which means it was turning out models that are more complicated wouldn't be ONNX exportable, which is why we thought like we want a robust solution, and that's the 1.0 story.
That's great. So so instead of kind of these separate steps of exporting and then importing into a different framework, you have kind of like squished all these steps into one thing that you can do in a hybrid front end. That does sound ideal.